Hi everyone, welcome back to CS 128 Honors. Today we're going to have lecture 9, which is the second part on structs. Again, this will be a short lecture and we'll mainly be talking about functions that are related to structs. So today we'll cover structs in Rust, methods, debug traits, and associated functions, not associated types. So the optional reading will actually be chapter 5.2 and 5.3, mainly 5.3 because 5.2 is just primarily a worked example. So just a quick recap, structs are short for structure and they're essentially composite types that hold multiple related values, right? So here is an example. We have a struct car and each of these kind of line inside here are called fields, and each field has a name sorry, and each field has a name associated with it, for example brand, make, MPG. So to actually use a struct, you have to instantiate like a specific instance of a struct. And for example, here we have car, and then we have to create concrete values for each field in the struct. So here we have another example struct. Today we're going to go through a new one. So for example, we create a struct rectangle, which has two parameters, just two fields actually, width and height, both of an unsigned 32-bit type, right? And here is a specific instance that we created called rect. So for example, now we want to calculate the area, right? So simply enough, we can just write area equals to rect.width times rect.height. So all this so far so good, right? But now let's think about it. What if we have a more complex function, right? So for example, we don't want to just calculate the area. We want to find the angle of a diagonal. We want to invoke some other procedures or some other functions in the Rust library. So if we write everything directly in a line like this, we'll actually have a lot of code repetition, as well as a different code for different instances, which is not ideal, right? Because then you actually, like I said, we repeat the code, and then every time you create a new instance, for example, if you're rect 1, rect 2, rect 3, you'll have to change the kind of invocation here to rect 1, rect 2, rect 3. So actually the solution should be quite straightforward, right? Just put everything into a function, right? So simply put, for example, here we create a function called rect area. All it does is takes in a reference, notice this, it takes in a reference to a rectangle struct and it returns the area, right? So this helps us to solve our problem of code repetition, as well as repetition across different instances, right? So actually Rust have a kind of way to help us deal with that, and it's basically this thing called methods, right? Methods are functions that are defined within the context of a struct, and we'll soon see how we actually define it, but it helps a lot with code organization, and it also helps you to write correct code more easily. So for example, with the function syntax that we defined earlier, with this, let's see, where did my mouse go? Okay, so with this rectangle instance, rect, with the function that we wrote earlier, we'll just call it like this, and we'll call the function rect area, and we'll pass in rect as a parameter, as a argument to the function, right? So actually, with method syntax, which we'll introduce shortly, you can actually do this. So we can call the instance rect and then use the dot notation. So rect dot rect area, and this will automatically calculate the area of this instance. So the difference here is that we don't have to pass the instance into the function anymore. So how do we actually define a method? Hold on, the computer is lagging. So to actually, okay, back to the lecture. To actually define a method, what you need to do is this write this IMPL, which is some people call it an impl block, but basically it's short for implements, and basically you just IMPL and then the type. So the type here we have is rectangle, and inside here every function that you define inside there will be called an associated function, right? And specifically for methods, you will actually take in the first argument that you take in will actually be the instance itself. So for example, here we create a new associated function called area inside the implement block for rectangle, and then here we actually take in the instance self, And then what the area function does, it returns self.width and self.height. So far so good. Yeah, so this was basically what I said earlier. So actually, just to add on, this ampersand self is actually a shorthand notation, and it's actually short for basically self and then colon ampersand self. So it's basically the same notation that we have, which is the name is self and then the type is ampersand self, right? Or ampersand rectangle in this case. So Rust actually allows us to have this shorthand so that we don't have to write things in this kind of longer notation. So recall that we have already talked about ownership, and we remember that this is actually a reference. So on top of a reference, a method can actually take in a mutable reference, or it can actually take ownership of the whole object itself, which means that when you call the function, the ownership of the instance is moved into the function. So we'll see examples of each. So for example here, in the implement block for the rectangle, we create another function called change width, and the first parameter it takes in is no longer a reference to self, but it's a mutable reference to self. This means that we can actually modify the instance within the function itself, right? So this function, quite simply, what it does is just it changes the width to the new width that we have defined. Another way that the method can be called is when it takes ownership. So here we don't have the ampersand symbol, which means it's no longer a reference. It takes the ownership of the instance, and specifically in this case, it returns a completely new instance. So it takes ownership and returns a new returns ownership as well. So what happens is here it takes in the rectangle, and then it returns like a completely new rectangle instance. And lastly, just as an example, you can also take in the instance, like take ownership of the instance, and then don't actually return it. So in this case, if you call this function, the rectangle will actually be moved into this function and it will no longer be usable. So I mentioned associated functions earlier, and just to define it more clearly, any function that is defined in the implement block of a struct is actually an associated function, right? But we've already covered associated functions that take in a reference, a mutable reference, and take ownership of the instance. But what about functions that just don't take in any parameter, or more specifically, it doesn't take in the instance, right? So those exist as well. They're also associated functions, but they are no longer methods. So methods have to take in the instance somehow, either through a reference or through taking ownership, right? So when we create this kind of associated functions that are not methods, they are actually tied to the type. So they'll be tied to the rectangle type rather than specific instances. So it's a bit like static methods in a class in Java. So one example that is commonly used is for constructors. So here we define a constructor with the function new, and notice here it doesn't take in ownership, it doesn't take a reference, it doesn't take a mutable reference. What it does is that it's a function new, it takes in the width and height, and it creates a new instance, right? So actually, how do you call that? The syntax to call that would be the type rectangle with two colons, and then the name of the function itself. So another example would be, for example, here I create a function called description, right? And then it returns a string which basically just writes, oh, I like parallelograms more. So if you notice that this string from, notice that this is also a associated function that isn't a method of the string type, right? So this is another place where this is used. So again, just to write out the differences, there's not methods, or like associated functions that are not methods versus associated functions that are methods, right? The ones that are not methods, you will call it like this, using the type, and then the function. Whereas for the methods, you can use the instance and then use the dot notation. So lastly, just quickly, I want to cover the debug trait. So the debug trait is useful because it allows you to print out the kind of values that you have in a struct, and this is really useful when you're trying to see what is inside the struct when you're debugging and like trying to fix your code, right? So all you have to do is do this like hash square bracket derive debug, and what it does is it derives the debug trait, right? We'll cover traits in a future lecture, but for now, know that this is the only line you need to add on top of your struct. And what happens is that now you can actually print out your struct, right? So for example, here we do print line, and this is the notation to do a pretty print. You can do like a colon question mark, like a colon hash question mark, and it will print out the struct either in a line or like with each field in a new line like this. And this is really useful for debugging. Yeah, so that was the end. So just to recap, we have finished covering structs, which are composite types with named fields, and associated functions are just any functions defined in the implement block of the struct, right? So associated functions are split into methods and not methods. Methods are called on a specific instance, so they take in a reference, a mutable reference, or they take ownership, and the ones that are not methods are called directly on the type. So for example, it is the type followed by the not method, right? So lastly, we talked about the debug trait. Essentially, you add this line on top of your struct, and it lets you print the stuff nicely. So just some announcements. Today we've released homework 7, and it's due next Wednesday, 2359. And MP1 was released last week, and it's also due next Wednesday, 2359. So we have office hours almost every day of the week. So feel free to ask in Discord or go to office hours if you need help with any of the homeworks. They shouldn't take you very long. Again, like we've said in the syllabus, homeworks should take you around 30 minutes, and maybe the MPs will take you around 1 to 2 hours. So have fun coding Rust.